Previously, we talked about the design of reinforced concrete member subjected to the combined actions of bending moment and torsion. It was mentioned that under normal circumstances, as long as the bending moment acting onto the member does not exceed 80% of the ultimate moment capacity, there is no need for you to do calculations to determine the torsional reinforcement. There are three circumstances where the calculations for the torsional resistance is required. First, it is when the 80% ultimate moment capacity has been exceeded. Second, it is when the torsions has been included in the original analysis. And third, it is when torsions is required for the equilibrium of the member. These are summarized in the diagram here. Now let us proceed with the second part of the discussion here. It is regarding providing the reinforcement in resisting the torsional load. First, you need to know that the reinforcement that we are referring here is the longitudinal steel bar, as this longitudinal steel bar plays a significant role in the bending moment resistance. We are not talking about the link. The link is more relevant to the combined situations of the shear and torsion. Why is it so? Because the shear resistance is mainly contributed by the link. To make it simple, if you are designing a member subjected to the combined shear and torsion, the emphasis it will be on the link. However, don't forget that the influence of the additional tensile force due to the shear reinforcement. That means under the combined state of the torsions and the shear, you also need to consider the longitudinal bar that is meant for resisting the additional tensile force due to the shear reinforcement. However, if you are dealing with the combined moment and torsion, the emphasis it will be on the longitudinal steel bar. Now, when you need to design for the moment and also torsion, you have to calculate the longitudinal steel bar separately for the flexural load and also for the torsion, especially when the member is subjected to bending. There will be regions of the tensions and compression. Now, if the sections is relatively large as compared to the moment acting onto the member, you can always design the member as a singly reinforced member, where the moment resistance is mainly governed by the tension reinforcement, whereas the compression bar is theoretically not required, although you will need at least one bar at one corner to hold the link. In the case that the compressive strength given by the concrete is insufficient, you can always reinforce with additional compression bar. This will lead to doubly reinforced section. Coming back to the design of the torsional resistance of the member, where the steps and the considerations at the tension region and at the compression region differ slightly. We will look into them one by one. First thing first, you need to first decide whether torsional calculations is required or not. If you are talking about the normal cases and the moment capacity is used at less than 80%, no calculations for the torsion shall be required, and you can simply use the longitudinal reinforcement bar that is meant for bending moment without any reinforcement for the torsional resistance. However, if the bending moment acting onto the member exceeds 80%, or if the torsion needs to be considered, then the calculations for the torsions will be necessary. Knowing that now torsional resistance will be necessary, then we have to look into the tension zone and the compression zone. Let us first look at the tension zone. In your initial design of the bending moment resistance, there will be a set of longitudinal steel bar. And then for the torsional resistance, there will be equations for you to determine the longitudinal reinforcement. This longitudinal reinforcement for the torsions will be added with the longitudinal reinforcement for the bending moment. The final amount of reinforcement to be provided, it will be the summations of those required for the bending moment and those required for the torsional load. I believe this part you have no issue since we have mentioned about it quite a number of times in our previous video. Now, how about the flexural compressive zone? This is where the concept of singly reinforced and doubly reinforced section comes in, although it appears in slightly different manner. You see two different cases here. Let us deal with the simpler one. Theoretically, you will need to calculate the longitudinal force caused by the torsional load. This longitudinal force shall be compared with the compressive force of the concrete. If the longitudinal force due to the torsions is less than the concrete compressive force, that means this compressive force can be used to withstand the longitudinal force due to the torsion. As a result, no torsional reinforcement shall be required. The final reinforcement at the compressive zone, it will be as required for the flexural resistance. Now, in the case that the longitudinal force due to the torsion is more than the concrete compressive force, that means the compressive force of the concrete is insufficient to take this longitudinal force due to the torsion. Because of this, the longitudinal steel due to the torsions shall be added to the existing amount of reinforcement bar to be placed at the compressive zone. It is interesting to note that the additional amount of reinforcement here is not determined on the basis of the differences between the longitudinal force and the compressive force due to the flexion. This longitudinal steel due to the torsions are not meant to take the balance in between the longitudinal force and the compressive force. This approach is slightly more conservative. If the torsional load exceeds the resistance in the compression, you will assume there is no resistance from the compression. This longitudinal force due to the torsions will have to be fully taken by the longitudinal steel that is meant to resist the torsional load. As a result, the final amount of reinforcement bar, it would be the summations of what is required to resist the flexural load plus the amount what is required to resist the torsional load. With that, this concludes the design for the combined actions of the bending and torsion. To make it simple, there are two decisions that you need to make. First, do you need to do calculations for the torsion or not? Second, do you need to add the longitudinal steel bar for the torsional resistance on top of the longitudinal steel bar that is required to resist the flexural load? We have mentioned about the circumstances where you do not require the calculations for the torsional resistance, whereas the rest you will require the torsional resistance calculation. And then you also observe that by the time you are designing for the torsion, you should have already done designing for the flexural resistance. One way or another, the longitudinal reinforcement for the moment is already there. Just that now you need to decide whether you need to add longitudinal reinforcement to the originally provided longitudinal reinforcement. There are two cases the torsional reinforcement needs to be provided. First is at the tension zone. Tension zone, you have no choice. You must provide the longitudinal reinforcement for the torsional resistance. As for the compressive zone, the torsional reinforcement it will be required when the longitudinal force due to the torsions is greater than the compressive strength under the flexural